Okay, our next lecture, solving systems using linear combinations. You can see we're going to take a 2 by 2 and a 3 by 3 system, which means 2 equations, 2 unknowns, 3 equations, 3 unknowns. Looks a lot like matrices, but we're not going to be dealing with matrices at this point. We want to be able to recognize properties of systems of equations and use those systems of 2 and 3 linear equations to show real-world problems. So, moving forward and showing you what that's about. Remember, we just finished substitution, and we've been doing this pro and con thing. So we talked about these right now. You should be able to tell me the pros of substitution and the cons. And you should have some ideas, so I'll write, and you work here. So if you would, the pros, do these now. We definitely got an accurate answer when we did substitution. Okay? And from there, once we got that accurate answer, that was really big. That was what we were looking for after graphing. But now for some of you, it's a little confusing. And if it's not confusing, some of you would say it's long. It's a long process. Okay, so substitution, accurate, definitely is. Cons, again, would be that it's not visual. So right now I say we're getting a few more. Maybe you can come up with a few more pros, and we can discuss those in class as well. But right now, probably the biggies here are that we now have an accurate situation. And probably what most people say, it gets a little confusing with all the substitution. So we got to be able to figure a way to undo the confusion. And accuracy is still big. So confusion is probably the biggest thing we got to worry about. So knowing that, we're going to try something called linear combination. I like to also name it elimination. And there's basically two things. I like the name elimination because it tells you what you're going to do with the variables. So solve a system using linear combinations and elimination. Most of our equations will be linear based. So starting off, we're going to use the same coefficients, and you must eliminate them by adding or subtracting. So think about it. If I give you 5, the number 5 or 5x, and asked you to eliminate it, there's only two ways you can do that. You could take a 5x and subtract another 5x, and it would be 0. Eliminate makes it gone. Or I could take that 5x and add a negative 5x. So that's where the adding and subtracting that I'm talking about here comes into play. So let's start with two equations. This time, we highly recommend that you stack the two equations, sort of like old elementary style addition and subtraction. And from there, you want to start looking at what variables can I eliminate. So in eliminating here, we want to look at the y's, and if we added right now, the y's would go away. So if I added 1x and 3x, I get 4x. 1y and negative 1y, 0. 8 and 4, I get a 12. That's a one variable equation, so solve it. Divide by 4 on both sides, and when you do, x equals 3. Now take that x value that you just got and take it up and substitute it into one of those two original equations. I always say pick the easier one, so in this case I've chosen that top one, x plus y equals 8. If 3 goes in for x, then you can almost do that mentally. Y has to be 5. So this tells you that your ordered pair x, y is 3, 5, which means, going back to our situation, that these two equations, if I would graph, would overlap, cross, intersect at the point 3, 5. So we found that same point that we did by graphing, without graphing. We found it accurately, and it was pretty straightforward. You just have to decide how you want to write these. Okay, knowing that, let's move on to the next question, which is, well, what's going to happen when you have different coefficients? So here we go. All right, what if? What if it's just not so easy to add and subtract right away? Here's our two equations. If I look at the 3 and the 9, they do not eliminate. I look at the 2 and the negative 8, They do not eliminate. And I can't even check the numbers. We're only looking to eliminate a variable. So I have to choose the x's or the y's. But notice, in both situations, if I would multiply that top equation, I could make the x's similar. Or if I multiply the top equation by 4, I could make the y's similar. It's your choice what you want to get rid of. I would always say go small. So multiply what there is the smallest. So you can see I've multiplied the top equation by 3. 9x plus 6y equals 66 is our new equation. Second equation stayed the same. 9x plus negative 8y equals negative 4. I now have 14y equals 70. I divide by 14 and I get a y equals 5 value. Again, use either one of the originals. This one's a little more complicated. The equations are a little tougher. But go ahead and substitute the 5 in for y. Be careful you get it in for y and not x, as we did here. And then do the math. Once we get 3x plus 10, we move the 10 over. We divide by 3. X equals 4, and we'd already gotten our y value, so 4, 5 is the solution this time. That again means if I would take these two equations and graph them, we would have intersection at the point 4, 5. So they are linear equations crossing at 4, 5. We'd have one and only one solution. Pretty slick. If you don't have variables that eliminate by adding or subtracting simply, you can always use this multiply trick. And I would multiply to get whole numbers. I wouldn't multiply to get fractions. That makes it easier. It's not impossible to use fractions, but whole numbers, your comfort zone, stick with those. Okay? On the next one, what if we go bigger? Now I'm going to get you started on this one, and then I think I have one that you're going to try. If I have 3 equations in 3 unknowns, we need to get it down to 2 equations, and then do exactly what we just did, and keep going from there. So if I start looking at this one, I would ask, what variable would you eliminate? And some people would say the A, some the B, some the C's. They're just guessing. Try to stay small and try to pick something you have to do the least amount of work with. If you said the B's or the C's could be eliminated on this one fairly easily, I would probably agree. Now, just to make this simpler for our practical purposes here, let's call this top equation A, the second equation B, and the third one C, just for reference purposes about what we're going to do. All right, I only can take 2 of them at a time and work with them and try to eliminate them. I can't eliminate all 3 variables right off the bat. So if I took equation A and B and tried to eliminate B, the letter B, I think I'm going to have to multiply equation B by 4, and I will add that. So B gets multiplied by 4, and I will add that to equation A. So that's going to be my work here. So equation A, I'm just going to copy. And now equation B, I'm going to times by 4. So 2 times 4 is 8A. Plus 4 times negative B is negative 4B. Plus 4 times 3 is 12. Plus 4 times 35. If you can't do that in your head, you can always bring your little cheat sheet over and do your little multiplication, or have your calculator nearby so that you do multiply it accurately. So 4 times 35 should give us 140, especially if the numbers get a little big. Now look at your values. It's the B's that are going to be eliminated, and we are adding. So keep that in mind. You may even want to put that out front. So you can see we've got an 11A. The B's would go away totally, plus 17C, and that equals 162. Okay, from there, come over and choose 2 different equations. Can't choose A and B, and again, we want to get rid of the same variable we eliminated the first time, which was B. Okay, so probably B and C, and it looks like this strategy this time we're going to have to multiply equation B by 3, and we will add that to equation C. All right? So here we go. Equation B has to be tripled. 2 times 3 is 6a minus 3b plus 9c equals triple that would make it, I believe, 105. 3 times 35. Add it to c. So c as is, so 7a plus 3b minus c equals 26. We're just copying. Underline those two equations. Look at your b's. The way they're going to be eliminated again is by adding both these equations together. So add down 6a plus 7a, 13a. The b's would be gone. 9c plus a negative 1c is 8c. 105 plus 26 equals a 131. So you now have two equations. They both have a b eliminated. You would look at them. I'm going to write this one underneath here so we can compare them a little better. And now we would be asking you to eliminate another letter, either the C or the A. And for all purposes, you would have to decide. This is where I want you to finish it from. So you decide what you want to get rid of, either the A's or the C's. You're probably going to use your calculator because we're getting into some bigger numbers, and decide what they go into. Remember, as an example here, if I don't know how many times 11 goes into 13, or I can't find a number 11 and 13 both go into, don't forget that they always go into each other when you multiply them. So I could multiply this bottom equation by 11 and this top equation by 13. Again, it's going to give us some pretty big numbers, so have your calculator ready. But I could do that, and then I could eliminate the A's. Be careful how you do that. Are you going to add or are you going to subtract? Remember, if they're opposites, you should be adding. If they're exactly the same, you should subtract to eliminate. All right. Now, on this one, these next couple questions, we're not going to solve them. I just want you to look at them and decide now what method. We've done graphing, we've done substitution, and we've done this linear combination. What would be best based on how the original problem is written? So look at this one. 3x, 2x, 2y, 5y. It's in standard form. Things are lined up. I don't see any x's or y's by themselves. I think elimination or linear combination, whatever you want to choose there, would be your best bet. Quickest. Doesn't mean it's the only way. Graphing and those will also work. Next one. Look at this. Would you use graphing, substitution, or elimination? And on this one, you have a couple choices. I would go probably quickest with substitution. Because if you took that top equation very quickly and divided both sides by that negative 3, you would have an x value. And then that x value, which is negative 12, should be able to be substituted down here, and you get your y value fairly quickly. No graphing necessary, even though some of you might have said, well, x and y are almost by themselves. I still probably would go with substitution. Efficiency. On this one, look at it. Graphing, substitution, or elimination. I'm looking at the y's. One's positive, one's negative. They're ready to cancel right now. That one's going to be done in a few seconds if you use elimination. Okay, use that as your line and start going. You do not have to solve. Now somebody said, well, y is almost by itself. I could graph. That's going to be a lot more work, I believe. So most efficient way on this one would be elimination. Looking at this one, I believe same thing, elimination. I'm going to get the y's eliminated immediately by adding these two equations together. So it's not that we now have three ways and we can pick our favorite method. Graphing has its pros and cons. Substitution has its pros and cons, and linear combination or elimination has its pros and cons. You have to get good at all three, know what you're looking for, and be able to solve using all three methods. So this method today, we're going to be honing in on